Okay, I actually wanted to do this example of 46 in two parts because this very last part, I wanted to actually talk to you about finding the second derivative of an implicitly defined curve. So in this example, we want to find d squared y by dx squared, or y double prime, or the second derivative of y with respect to x, with this implicitly defined curve. So I'm not solving for y equals something. I'm just leaving it in this form. 2x cubed minus 3y squared equals 8. Okay, so all you have to think about is the derivative, the second derivative is the derivative of the first derivative. So the first thing we have to do is find the first derivative. So to find the first derivative, we have to use implicit differentiation because I'm not solving for y equals f of x. I just have it implicitly defined. So I take the derivative of both sides of the equation. So the derivative of 2x cubed is simply 6x squared, right? That's a simple power rule. And then the derivative of minus 3y squared. So that's I got to use the chain rule, right? Because y is an unknown function of x. I'm not solving for y to see what it is. I'm leaving it in this form. So I first have to take the derivative outside. Bring the 2 down. I get minus 6 times y to the first power. Then I multiply it times the derivative inside again. The derivative inside is y. I don't know what it is, so I just write it as dy dx. Equals the derivative of 8, which is 0. So I have a simple algebraic equation to solve for dy dx. Subtract 6x squared from both sides. Divide by minus 6y. I get dy dx is x squared over y. Okay, so that's the first derivative. But now what I need is the second derivative. So I take the derivative of the first derivative. That is the second derivative. So the derivative of the first derivative. So that means I want the derivative of x squared over y. So in this case, I'm going to use the quotient rule, right? I have a function divided by a function. So I'm going to say low, which is y, d high, the derivative of x squared is 2x, minus high, x squared, d low. So the derivative of y, I don't know what y is, so I just have to write it as dy dx. Divided by low, or y squared. Now, to actually see what the second derivative is, I don't want to leave this first derivative in terms of that because I already know what it is. It's x squared over y. So I take that x squared over y and plug it in for that first derivative. So this dy dx is x squared over y. Then I can simplify this if I want. So I get 2xy minus x to the fourth over y, all divided by y squared. So I could bring this together into one fraction, my common denominator. So then I'm going to have 2xy squared minus x squared, minus x to the fourth over y, right? So then that y times y squared becomes y cubed. 2xy squared minus x to the fourth over y cubed. That is then the second derivative, again, all in terms of x's and y's because I never did solve for y, and implicit differentiation either we can't or we don't want to.